different deployments is extremely hard. In fact, I don't know how, if it at all is possible in current, with the current set of tools. And for our current purposes, for today's discussion, we will consider your local laptop or your desktop to be multi-cloud as well. It's just another instance of the cloud. All right, if we look at our experimentation stack, when you are building a model, you're training locally, trying things out, you have a lot of stuff running on your laptop and enabling you, starting with hardware at the bottom with accelerators, operating system drivers, runtime, and then storage. And on top of this, you have your frameworks that you actually use to train and build your models. On top of the stack on your laptop or your desktop, you're going to be installing a bunch of microservices that enable you to compose and create your workflow, all the way from reading in data, training, and then testing out your model, making predictions. Now we take it a step further. You've got to do this whole thing over and again when you actually want to train your model at scale. We all would love to train the models with the volume of data that we have available. The more data sets, the more data points you are able to use, hopefully you get better accuracy in your model. And then finally, you actually want to deploy your model onto cloud where actually the endpoints are accessible to users and they're actually making a difference in the real world, the actual intention of your model. For all three of these environments, unfortunately, right now in the current set of technologies that are available, you have to literally redo a lot of this stuff. What you did in your experimentation stack to actually build your model is not exactly what you can take to production or deploy on the cloud. And there's a ton of work involved in making that happen, which is why we thought of building Kubeflow, and we started this effort. Our mission literally is to make it easy for everyone to develop, deploy, and manage portable distributed ML on Kubernetes. So in summary, essentially the platform is going to allow you to run Kubeflow wherever you can run Kubernetes, on whatever cluster, whatever cloud, whether it's on-prem or some kind of cloud platform. If you can run Kubernetes on it, you can deploy Kubeflow on it and take your technology stack along with it, including your local machines. You can run Kubernetes on your local machines as well. With this technology, essentially this is what your stack should look like. You are literally working with Kubeflow services, and whatever you deploy and develop, you should be able to translate it across all the environments without much effort. Looking at what's going on inside Kubeflow, we have a bunch of microservices that we rely on in building our ML workflows. And we have integrated a whole bunch of components, some coming from Google itself, from TensorFlow, TFX, and others from open source community, including things like TF Transform, NumPy, Spark for data transformations, TF Data for data validation, Jupyter for actually a development environment where you experiment and build your model, TF Job, MXNet, PyTorch to actually train your model at scale, and TF Serving, Seldon, TensorRT for serving your model at scale with the kind of latencies you want, and Prometheus for monitoring. There is more stuff that we can fit on the slide, but also there is, you will notice there are boxes which are right now missing components. So we do need to kind of like build out more components and get community to get involved and incorporate their solutions into the platform. All right, so that was kind of the backstory on what Kubeflow is about and like how it kind of like lets you translate your solutions across different platforms. I want you to spend some time on this slide and think about like what the user experience is going to look like. People who have done development of models, we want to kind of like see what is the workflow you will be going through when you are trying to figure out how you develop and build your model. One of the important goals of Kubeflow is really creating a low bar and high ceiling experience. What do I mean by high ceiling? If you notice the way Kubeflow is designed on top of Kubernetes, it does not restrict any Kubernetes level APIs. And in every tool that is available on Kubeflow, you should be able to configure to your heart's content, and in whatever environment you are. There's a lot of complexity in enterprise world, a lot of challenging networking setup and different kind of environments that you might have to optimize for. And the configurations in Kubeflow should allow you to be able to go down in the detail and modify whatever it is that you need to make it work in your environment. But on the other hand, we want to enable users who are not familiar with Kubernetes to be able to access this platform and be able to build their ML flows without having to worry about learning Kubernetes. Similarly, on the data science front end as well, I mean, there are engineers who are just starting learning data science. They have a lot of good background in Kubernetes and systems, but they might not be that familiar with data science. We want to create a low bar for them as well, have tools that will enable them to build data science, machine learning products without having to go too much into detail of learning various technologies, if possible. Okay, with that in mind, I would like to present an example which will walk us through the user process that we just, user experience that we just talked about. It's specifically focusing, I think a lot of you are already familiar with what a GitHub issue is. Generally, if you go to GitHub, I think there is a content associated with the actual issue where you have all the details and then you title the GitHub issue with a title that seems to fit or describe, summarize what the issue is all about. The problem we are going to be looking at is essentially a user filing a bug, and when they are running into some issue, they are not in the right mindset, and they're really troubled about what's going on, and all they want is like to paste that error, provide whatever information you want to provide, and then file the issue. That might not be the best time to think about what exactly is going on and what should the real title for the bug be. So with that in mind, one of the data scientists at GitHub, Amel, actually thought about this problem and felt that he can come up with an ML algorithm or an ML model that will look at the content, analyze it, and hopefully suggest a title that is relevant and helpful. So I want to thank at this point Amel from GitHub who actually built this model, and Ankush and Michelle who helped productionize this into an application on top of Kubeflow. And while I'm at the stage of thanking people, I should also thank a whole lot of other people. None of the content that you're seeing is actually my creation. It's a lot of people who have actually helped create it. And I personally really want to thank Jeremy, who's around actually right here. You should please meet him when you can. He's our tech lead of Google Kubeflow engineering team, and he conceptualized, formulated the idea around Kubeflow starting in 2017, and then in December 2017 announced this to the world, along with our product manager, David Aronchik, who's not here today, but he's also one of the founders. So the two of them co-founded this project and really defined the vision and the technology that will go into making this happen. And to this day, we rely heavily on them to provide us the direction. I would also like to thank Google's Kubeflow engineering team. Without them, none of this would be possible. And of course, the Kubeflow community. We really love our community. They are extremely inviting, open, friendly, and they help us a lot with figuring out solutions to these problems. All right, moving forward, the first step that we were talking about in the user experience was deployment. And this is something really fresh, actually. This is not directly available so far, but I want to give you a preview of like what deployment experience would look like with this application that we have been building. And this deployment is a deployment of Kubeflow on top of Google Kubernetes Engine. As I mentioned, you can deploy Kubeflow wherever Kubernetes deploys, whether it's Microsoft Azure, AWS, or some other cloud or your on-prem hardware. But we are specifically focusing in this presentation on a GKE-based deployment. You start with a few set of fields. You talk about providing information about the Google project, cloud project that you want to deploy the stack on, and give the deployment a name, and then provide some kind of authorization information, and then be able to say click deployment. And a few minutes later, you should be able to view your cluster along with the services running on your Kubernetes Engine dashboard. So what this is showing, sorry about the small font, but essentially these are some of the core services that Kubeflow deploys on your cluster when you create the deployment. A lot of these are fundamental to stitching together your workflows or your process to train or deploy a model. The URL here that you're looking at is essentially a way to get into an access point into your Kubeflow cluster deployment. Everything by default, the way it is deployed is protected in your cloud project and not accessible from an external IP. With the exception that we create this ingress point which has IP protection, Google IP protection. that allows you to access and authorize any access that is going into the cluster. So if you click on that link, it takes you to the Kubeflow dashboard. Right now it's very minimal, and we are working on figuring out what is the right information that should go in here and what all makes sense. But at this point, it kind of like helps you bounce off to a few things that you are most commonly going to be doing. The first thing that it will help you get to is the Jupyter Hub, which is where you will be actually doing your development, and that is the next step in the deployment process. I do want to take some time here and look at, referring back to our principle that we talked about of low bar, high ceiling. We created the UI, web UI-based driven deployment process to lower the bar on deployment, to make it easy for data scientists who are not familiar with Kubernetes to get onto Google Cloud and be able to create their Kubeflow cluster without much effort, just a few clicks and a few keystrokes. But on the other hand, we want to ensure that anybody who's familiar with what's going on has complete control on what their deployment is going to look like. So on that front, this CLI-based deployment uses Kubeflow, which is our command line tool, and it lets you control your deployment with 4 sets of commands: init, generate, apply, and delete. We see an example of how that workflow goes for deployment on the right side. So you start with initializing your deployment. It ends up like reading a few parameters and environment variables, determining what your cloud configuration is going to look like, and then creates an environment variable and inits a directory which is going to be your Kubeflow application, referring to your Kubeflow deployment. Once that is done, then you can, and in this instance again is pointing to a GCP, Google Cloud Platform, so it will end up creating a GKE cluster. The next step is basically generating the platform, and what that generate does is it generates a lot of configuration about what your GKE configuration is going to look like. The benefit of this is that that generated set of configuration is available locally from where you are doing deployment, and you have access to that configuration. You can go look in there, browse around what's going on, and you are able to tweak a lot of stuff and modify things if you want to create additional node pools, you want to add GPUs right from the beginning, or you can make a lot of configuration changes in there, whether you want to have IAP or not, essentially. And the next step is going to be apply the platform, which would actually take the configuration that it generated in the previous step and then actually talk to Google Cloud Deployment Manager and create the GKE cluster that was defined by the configuration. The next step is going to generate the K8s about, which are basically configuration for the various services that are deployed in your GKE cluster. So in one of the previous slides when we looked at the GKE cluster, it had a list of services that are running as part of core Kubeflow. The configuration for those services is generated by this command, and apply would again go ahead and apply that. But intermediates, if it allows you to keep that configuration available and modify in whatever form you feel is needed. Switching back to the Jupyter notebook, you go to the Jupyter Hub, and this is the page you land on, which allows you to create a Jupyter notebook. If you notice here, the first field in here is letting you choose a container image. We have a few pre-built container images. These are Docker container images, which already have TensorFlow support for different versions of TensorFlow, along with images built for CPU or GPU. If you want, you can just click spawn at that point and then say like start my notebook. But it also allows you to configure further and specify how many cores you want. So if you know your workload is going to require GPU, you can go ahead and specify that you need GPU containers, and then you can specify how much memory you might need. Once you've created your notebook, you're inside the notebook, and this is kind of your playground where you go around, you can import TensorFlow libraries. If you are working with some other Python libraries, PyTorch, you should be able to pip install packages here as well, and then you have access to those packages, Python packages. You have access to pandas, whatever other Python tools you might want to use. This is where you will spend a lot of time iterating through your model, figuring out what works, what doesn't work, and how do you want your model to look like, connecting to various data, and actually training your model. Remember that at this stage you are still running inside your container that has got the Jupyter notebook running. So you're only working possibly with a reasonably sized data set that will allow you to iterate and experiment on your model. Once you have figured out what your training script is going to look like, the next step in the process is to build a Docker container image. Currently the process involves defining a Docker file which will specify what your Docker container needs to have installed. So for example, if you need to install a few Python packages, you will have corresponding pip installs in there. And then you copy in your training script, Python script that you had from your notebook. You can create a corresponding Python file, and you can include it in your container image, along with any other supporting libraries you might have written that you want in there. And once you have specified the Docker file, then you will use docker build command to build the Docker container image, and then gcloud to push it to cloud, from where you can actually then use the container image to create your training jobs. Another thing I do want to call out here is looking back at the low bar, high ceiling. I think for a few data scientists, this might be too much. They might not want, they are probably capable of doing this, but is this where they should be spending most of their time? Which is why we are thinking of integrating this into a workflow that goes directly from the notebook, and you are able to take your training exercise and from there itself click on build, and then at the back of this it will actually create a container image for you. So there are different ways we are thinking of based on the feedback we are getting on how we can lower the bar at every step. All right, so let's look at the next step, which is the most exciting part for me at least, is to take my training script and actually run it on a distributed cluster, train a full-scale TensorFlow model. In any application that you deploy in a Kubeflow cluster, the way it works is, and I will go a bit more in detail in a few more slides, but essentially it involves generally two steps. Creating a configuration for your training job or any other service that you want to deploy on your cluster, and then essentially making sure that you have the configurations parameters specified appropriately based on what you need, like how many workers you might need, where the model's input is going to come from, where do you want the output model to go, and setting up sizes on what your training set is going to look like, maybe possibly. Once you have your configuration ready, then you can kick off your training job by saying, take this TF job configuration that we just defined and apply it on my Kubeflow cluster. And that's the KS apply command, which actually takes the configuration, then talks to the cluster and says, bring up these containers, get it running. And while that job is running, you would be able to use various kubectl commands to monitor the pods that are running the job, to access the logs, and figure out what is going on with the training job. Okay, back to the same, I keep coming back to the same theme, but essentially looking back at low bar, high ceiling, we do want to allow data scientists or anybody who actually just want a bit of flexibility and ease to be able to go and create their TensorFlow job configuration from a UI. And this is really possible because if we look at the previous slide, there was a lot of configuration which is defined for the job, and we can literally interpret and parse the underlying configuration and generate the UI corresponding to that configuration, and allow you to set the parameters not from the command line but from the UI. And here you should be able to point to the container image that you want to use, how many workers you want to use, and where to pull the data from, etc. Great. Once our model is trained, the next step for us is how do we serve this model? I believe the example that I present here is to kind of use TensorFlow serving. And you could use Selden as well, which is available in Kubeflow, and we have a GitHub examples repo that you can go and take a look at for the GitHub issue summarizing, for the GitHub issue summarization example, and then you should be able to look at see how the same thing can be done using Selden. In this slide, I will walk you through TensorFlow serving to serve the model. We talked about this KSonnet that we use. I want to give you a bit of background on what's going on over there. We use KSonnet, which is a configuration language which allows templating to describe various configuration. And the power of templating allows you to parameterize a whole bunch of things that you can specify and set and modify your configuration at the time of instantiation. So all Kubeflow components are described by a corresponding KSonnet configuration, which is available to you on your configuration directory that you created when you were deploying the cluster. From there, you should be able to create services by generating new service components using the template, and then configure the parameters as I'm doing here. We generated a serve inception component which is a brand new component from the TF serving template. And then we're setting a few parameters here talking about like whether we want an HTTP proxy, do we want to use GPUs, where the model is actually going to be stored, where to load the model from. And there are a bunch of other parameters that I'm not using, but you're free to explore and figure out what you want to configure. And then the last step, just like last time, is once your configuration is ready, you say case apply, and then it will actually end up deploying this component on the cluster and bringing up your model. Finally, deploying a web app around this is a very similar process. You would end up probably using Flake or some other Python library or whatever is your favorite tool to kind of build a web app against the server, the model that we just created. And once your application is ready, you can create a corresponding container image, deploy the container on Kubeflow, and then you have your UI to talk to your model at the back. I think I've been mentioning this over and over, but essentially that is the real theme here, is that we have been working on making sure that we get the breadth of the components that are necessary across the whole spectrum of the workflow, all the way from data ingestion to deploying and running your applications. There's a lot of work around this, more than we can handle by ourselves, which is why we are relying a lot on our community to provide us solutions as well. And we would encourage you to get involved as well. But while we work on this breadth, we do study our users and get a lot of feedback and figure out where they are having challenges. And we will leverage that information to drive lowering the bar and improving the experience on wherever we see there is pain in user experience. We have tremendous momentum. I think since the project went live early this year, late last year, early this year, we have over 1,000 plus commits now, 100 plus community members that are active, and roughly 20 plus companies that are contributing. And you can get live stats about this from our GitHub repo. Finally, I do want to mention Kubeflow is open. We are an open community. We love people joining our community and contributing. Open design, open source, and we are open to ideas, which is why we are hoping that more and more data scientists get involved. As I noticed today, there are very few data scientists. I would love for you to go to our website, kubeflow.org, go to our GitHub repo, file issues. Let's start there. Why don't you file issues on what is working, not working for you, and then we'll get you more involved, and hopefully you will have ideas to contribute. Thank you. And finally, I'll leave you with a few links, hopefully that will help you explore. See, I think we are doing okay on time. I'm happy to take some questions if you guys have. There's a mic at the back. If you have questions, feel free to go there.
One question I had is earlier we talked about different companies creating their own ML pipelines and things like that. Uber's Michelangelo, Facebook's FB Learner. How generalizable are you guys designing this, and do you think that this could the way you guys are designing could potentially apply to the use cases they have? And how are you guys kind of optimizing between being opinionated and being more general?
Right, I think we are starting from a place where we are not opinionated, and we want to allow the flexibility and allow the community to kind of come up with ideas and contribute. I think the biggest challenge at the beginning is to kind of get the breadth and make sure that we have components, we have support to cover the whole end-to-end workflow. I think one of the biggest challenges, if people are interested, is data connectors. This is a big pain point for all enterprise solutions, where people always ask us, like, can we have connectors to our data systems? And similarly, I think you mentioned Michelangelo, Facebook's FB Learner. All of them have various strengths, and I think we are welcoming them to come and contribute it to the OSS community and build it into the platform. We would love to have that. Not only those, if anybody else wants to build, we have a lot of contributors who have gone and made the effort to take their components but make them available, and we would encourage to continue to do that. Thank you.
So one of the
Oh,
things that
do you want to please use the mic?
Okay, thank you for the talk. So one of the issues, or one of the things that can help data scientists today is to know what the standard way of doing ML is, because there is none.
Right.
And how to do feature engineering, how to do serving, how to do training, and if we are doing it in a way that it is compliant with the enterprises, then being opinionated actually helps.
Absolutely.
So how do you see this?
Right, I'm not disagreeing. I think your question is very valid, and I do hear this from a lot of customers we talk to. A lot of them are at a place where they are, tell me one way to do this, and this that is what I want to do. I don't want to explore and figure out. So we do see a spectrum of people where there are really sophisticated engineers and teams that are actually, they want full control. But there are people who are actually interested in, like, this is my business problem, that is what I want to focus on, and just tell me how to kind of like do this. I do see a time when being opinionated would help, but I feel like at the beginning of the project, it is not the right time to form opinions where we won't even know what the right opinions are. I think it is time for us to kind of explore and allow the community to contribute ideas along with us, producing ideas as well. And hopefully we find out from our users, from customers, what works for them. We are willing to help them set up when they are confused or if they need some hand-holding and guidance. We are willing to put the effort. Our whole community is happy to do that in providing guidance. But I think I don't believe that if we start being opinionated right now, I think we will end up losing some good solutions, and we might end up creating a platform that is not usable by all. I think the whole ML space, in my opinion, is at a place where, as an industry, we don't really know what the right way to do all the things are. And we need to figure that out first before we can start imposing those opinions on people. Anyone else? Go ahead, please. Do you mind coming to the mic, please?
Good evening. My name is Paul. Thank you for the information. It seems like a really great tool to help a lot of people.
Thank you.
I've been hearing a lot about key stores, and I'm curious how Kubeflow would play with like key stores or managing identities.
Okay.
I know that you have like a IAM in the Google Cloud platform. Can you speak to that?
Right. I think we are relying for identity and access management on the underlying cloud platforms. For example, Kubeflow itself is not reinventing the wheel on a lot of like underlying cloud infrastructure. So on Google Cloud, we rely completely on. In fact, we will rely heavily on Kubernetes to design and define those solutions and leverage that. And in addition to that, when you deploy Kubernetes on different cloud platform providers, we will be leveraging the IAM solutions that might be available over there. Does that make sense?
Yes.
Thank you. Thank you, Paul. Great. Anyone else? Yes. Great.
Hi, I was wondering if you could help us position Kubeflow against some of those managed machine learning platforms and how you see it from the Google perspective.
Right. I think it will be a good idea to do that. There are definitely users, as we just discussed, who can benefit from managed services as well. And I think it's an important part of their experience where they are willing to experiment and go deep into certain areas, but there are portions of the ML workflow where they would not want to invest, and it will be great to integrate. I think that also ties into the question that Mark, I think, had asked about like how do we get FB Learner or, for example, Michelangelo or maybe Google Cloud's managed offerings to integrate into the platform. I think it is important for us to figure out integration points with those services. For example, people might be willing to spend time and are okay with things failing or experimentation going on in training phase, but they want to leverage the strength of Google's CMLE platform for serving. Or similarly, there could be other managed services that might be providing. So I think that's an interesting idea and very useful as well. We should definitely look at all those solutions as well. I would not discount any of those. Does that answer your question? Cool, thanks. All right. Go ahead, please.
Hi, thank you for your talk. My name is Satanas. You mentioned at the beginning that the goal of Kubeflow is also to deploy on not only on the cloud but also on other clusters.
Right.
Can you currently deal with other kind of cluster systems like HPC systems?
Right, that's a good question. So I think, we rely heavily on Kubernetes to provide us, provide us the capabilities on deploying on different platform. And on-prem is, for example, one such platform where we are working with certain partners who are focusing on making this work to work on like high-performance clusters. For example, if there are InfiniBand connects, or if there are other kind of interconnects that, for example, Cisco has some high bandwidth connections as well. So we would rely on some of our community partners to help us port these platforms onto those hardware platforms.
So this is currently still not available.
Right, I'm not aware of this, but I do know that, for example, certain of partners are working on the solution. Right, but this is certainly something that we are interested in. Thank you. Right, anybody from this side? I think I had a lot of questions from there.
This is a question because I personally had over the mic team, so
Oh,
it's accepted.
thanks.
I guess yeah, we can end the talk, but we can definitely we are here for any further questions. So we still have time to socialize and do a bit more informal Q&A. So if you want to hang around, we're still here. So, thanks.
Thank you. Thank you.